in the previous webinar, and at the end of the session we would announce the result, and also we have a quiz in today's webinar also, so all the students can attend this, and they are if they could answer everything correctly, they are waiting a surprise prize, and it would be a great prize, so everyone try to attend it. And I would also like to add on a small note to all the attendees. Please keep your cameras and microphones turned off and be proper discipline throughout the session. Now, I would like to call upon Sajin sir to give a more brief introduction of the guest.
Okay, thank you, Ritik, for being with us. He's a new student, recently joined with us and with Smart. And Mr. Varun is doing well to include more students to this program, and they are doing it well. So happy to see you here, Ritik. And today, good afternoon to all once again. And we all are sitting here on the 64th webinar of UL Space Club that is happening continuously. That still we are also seeing it is a wonder for us also because it is happening in every month with great personalities. It's in today's session we are with our second tenor with our honorable guest Dr. B.R. Guruprasad. Presently, he is chairing as the director of Jawaharlal Nehru Planetarium, Bangalore, is the new assignment he is received yet, and we are all proud to in his this position here, sir. And I welcome for all of us Dr. Guruprasad to this forum. And I welcome V.K. Kuti sir, Jayaraman sir, and P.J. Bhatt sir, and all other veterans from ISRO and current scientists, Ganesh Raj sir, and all the teachers, students who all gathered here. And today we have the session. Our co-host is my own school, Government Girls Higher Secondary School, Balisheri, and our principal is about join with us. Indu ma'am?
Yes, I have joined.
Yeah. Please. Okay. Then our honorable principal, Mrs. Indu R, already joined with us. And let me introduce today's speaker once again for this forum. Dr. Guruprasad is presently serving as the director of Jawaharlal Nehru Planetarium, Bangalore, and he was serving as an adjunct faculty member at National Institute of Advanced Studies, NIAS, Bangalore, and serving in the editorial board of member of Journal of Aerospace Sciences and Technologies. Worked in ISRO for 37 years and superannuated in 2020 as scientist SG and associate director in ISRO headquarters. Is an expert in satellite in the field of scientist, and he worked in German Space Agency and NASA, and he was invited to Japan 2008 in Japanese Aerospace Exploration Agency JAXA, and obtained his PhD from Mysore University in the thesis contribution of external and indigenous technologies element to the India's space capabilities. That was his topic, an appraisal at the affiliated National Institute of Advanced Studies also with that, and obtained proficient certificate in the subject of principles of flight in aeronautics, and written several books and broadcast extensively on the space related topics, and he was written more than 600 articles, and he has written 13 books, and all these are the evidences that he's engaged with his professional aspects, and at the same time his contribution in propagating science, especially the space science among the children of India. So we are proudly inviting our chief guest here to deliver his wonderful talk on the topic, the present golden age of asteroidal exploration. We know the asteroids are the wonders, and we are exploring the planets, and beyond that, we are going to the very difficult task, or the curious mind is doing to explore this asteroid belt over here. And we'll get a good talk from Dr. Guruprasad with his interesting subject and with a renewed subject. Before we are entering to his talk, I invite Mrs. Indu, our honorable principal, and she is the principal of my school, Government Girls Higher Secondary School, Balisheri, and proudly invite ma'am to chair this occasion.
Thank you, Shajil sir. Good afternoon, all. Respected Guruprasad sir, Kutti sir, Shajil sir, Bhatt sir, my dear teachers and participants. It gives me immense pleasure to co-host the 64th webinar session conducted by UL Space Club. As a person who has been participating in these webinar sessions from its beginning stages, I am really astonished to see the heights it has reached now. This platform has witnessed innumerable eminent personalities constantly interacting with the students. There is no doubt about the excellence and the mastery of them in their own disciplines. The versatility of the subjects dealt with in these sessions is also commendable. I am sure that UL Space Club has created a silent revolution through these webinar sessions. Such an opportunity opens new horizons to the young space aspirants. To the teachers also, these webinar sessions are a new experience. As a physics teacher, I myself consider lucky enough to get first-hand information from the pioneers of ISRO and to get acquainted with the new trends and developments in the fields of science and technology. In today's webinar session, Dr. B.R. Guruprasad sir will reflect light on asteroidal explorations. Asteroids have been considered both as an obstacle to space missions and also as a threat to life on Earth. We expect to get a clear picture about them and reframe our conceptions or misconceptions. Before I conclude, I would like to share with you that participating in these webinar sessions gives me a family feeling. Many of the student leaders, like Sriram D, are from our school, GGHSS Balusheri. Moreover, many of our students are regular enthusiastic participants here. The founder and mentor, Sri E.K. Kutti sir, is very dear to Government Girls Higher Secondary School, Balusheri. He has visited and participated in many functions here. And I am proud to say that the moderator, Sri Shajil sir, is a teacher of our school. Through Shajil sir and Kutti sir, the word mentoring becomes more meaningful. I wish more and more children get the nourishing and nurturing through them and through UL Space Club. Thank you. Thank you all.
Yeah. Thank you, Shajil Master. In fact, I still remember 3 years back, 3 to 3.5 years back, I gave my first talk here in this club, Space Club, Kozhikode. At that time, lots and lots of children came and they were all drawing and obstructing a lot. Those were the beginning days. I was speaking on human space flight at that time. It was a challenging thing for me. Today, you see, after having evolved, how orderly the thing is, either the crowd or the audience. So it is very nice to see this. And that is a reflection of how much of effort Sri E.K. Kutti sir, my well-wisher, and Shajil Master and all others who are running this club very enthusiastically and sustaining it and enhancing its stature day by day. So it is indicative of that. So I wish them well and good luck to all of you, sir. And congratulations for bringing this to this stage. I too get the regular invitation for the lectures. Now, I'm very happy. My special thanks to E.K. Kutti sir once again. And I'm very happy many of my seniors at ISRO, Vijay sir, PJ Bhatt sir, and our Mr. Sundaramurthy and my friend Dr. Ganesh Raj is there. So many of them and my friends Mr. Padmanabh Bhatt and Dr. Shashi Shivaswamy, they're all there. And I'm very happy. I'm really blessed. So thanks to them. And today, I'm going to speak to you people on a subject which is really interesting, no doubt about it, the present golden age of asteroidal exploration. Before I show the slides, the transparencies, first let me tell you one thing. Why have I called it the present golden age of asteroidal exploration? Is it a golden age really? No doubt about it. Because on September 23rd of this year, I repeat, September 23rd of this year, an American spacecraft, or rather to be more precise, a capsule contained in that spacecraft came back and landed on the Earth, okay, in the deserts of Utah, that state in the United States. So it had brought back more than 70 grams of asteroidal material from an asteroid called Bennu, okay. So that is an asteroid, very interesting asteroid. It had traveled, the spacecraft had traveled hundreds of millions of kilometers. I repeat, hundreds of millions of kilometers. And it came to Earth, and the capsule landed safely on the Earth's surface. And now they are analyzing the asteroidal material. Similarly, just last year, September 2022, a NASA spacecraft called DART, Double Asteroid Redirection Test. That spacecraft went and hit a small asteroid which was in turn circling a relatively larger asteroid. Why did they do it? Whatever they call as planetary defense. That is, tomorrow if some asteroid is in a position to threaten the Earth with its collision, as to how to prevent it, or how to rescue the Earth, or how to defend the Earth. That is what they wanted to test. And my dear friends, I know that this is for students. That's why I have made it as popular as possible, this lecture. The third one is, today, 2 NASA spacecraft are traveling to different asteroids. One of them is called Lucy, okay, which is going to explore 3 types of asteroids in the next 10 years or so. And very recently, a few days back, a few weeks back, NASA has launched yet another spacecraft called Psyche, P-H-Y-C-H-E, Psyche. That is the name of the asteroid. So towards that asteroid, a very important asteroid, NASA spacecraft Psyche. The spacecraft is also called as Psyche, that is proceeding. So like this, just 3 years back, yet another spacecraft, this time it was Japanese. It collected soil samples and rock samples from yet another asteroid called Ryugu. So like this, when all these things are happening, which are very, very exciting, and which help us understand, to know, and which help us fully comprehend the nature of asteroids, okay, their orbits, and many aspects related to that. So what else can I call this present time? Obviously, this is the present golden age of asteroidal exploration. That is why I have given this caption for my lecture today. Now let me go to the slide directly. I hope you can see the slides. I'll go to the presentation mode. Okay. So the present golden age of asteroidal exploration. Now, to the benefit of the students, most of them, let me start like this. Today, we live on planet Earth, which is the third rock from the sun, third rocky planet from the sun. After Mercury and Venus, we are the third planet, and next comes Mars. That is the fourth rocky planet. And the other 4 planets are gas giants. Okay. So today on Earth, almost 8 billion of us, okay, 8 billion of us, we are there. Okay. That is 800 crore people, humans, are living, excuse me, on the surface of the Earth. Was it the case always? No. If you go back to 65 million, more than 65 million years, that is, more than 65 million years ago, between 225 million years and 65 million years. That is 22.5 crore years and 6.5 crore years. Between that period, if anybody, any intelligent life form, ET, extraterrestrial, which is popularly called, if it were to come, okay, and see the planet Earth, if it were to land here and with its comprehending capability, if it were to see the planet Earth and the life forms there, it would have exclaimed, yes, this is the planet of dinosaurs. Okay, they were the giant reptiles. There was no sign of humans at that time. Even mammals, which are quite dominant, quite dominant. We also belong to the mammalian class only. Okay, so the thing is, this was not the case 65 million years back, and the life was dominated by dinosaurs at that time. Then, at that time, as has been widely accepted in the scientific circles, a space rock or an asteroid, okay, which is like the piece of a planet, let us say, okay, this rock, which was of about 10 kilometers in diameter, it came and hit the Earth. It was on a collision course with the Earth, and it hit the Earth with such tremendous force. Really, where did it hit? Even scientists have found out as to where it hit the Earth. Okay, in Mexico, okay, there is a place called Yucatan Peninsula, in fact. Okay, there, near that, the asteroid, the 10-kilometer wide asteroid seems to have collided, or it hit the Earth's surface, that is on water. And before it hit the surface of the Earth itself, it broke into pieces. Not fully, but many rocks were ejected out of it. And after that, once it collided with the Earth, it hit the Earth, the ocean. Anyway, it got immersed in water. And of course, the gigantic tsunamis got generated. And, the thing is, the rock itself, which rock pieces which got generated due to this collision, they went into they were thrust into the atmosphere, and again they came back and hit the Earth. The rain of rocks were there, hot rocks were there, molten rocks were there, and dinosaurs and many of the dominant species at that time, they got decimated. That is, they were killed. They became extinct. So dinosaurs especially. So goes the widely accepted theory today in science. In fact, thanks to this, a small mammalian creature like this called shrew, S-H-R-E-W, shrew, which is like a rat, it got survived, being very small, okay? The thing, and there was no competition from dinosaurs or other dominant creatures, which were predators. Okay, they proliferated, and mammals became dominant. And today we are about 8 billion, okay? 8 billion, that is 800 crore people on the surface of the Earth. Humans are the dominating species today. So, whether we have to thank the space rock 10 kilometers wide, which came and hit the Earth and decimated dinosaurs, whether we have to thank or whether we have to get scared about the future events, you only have to decide. Okay, but anyway, humans are not mute spectators like dinosaurs. Okay, we have the technology at our disposal, and at least we can make an attempt, a successful attempt to divert a threatening asteroid in the future, maybe to a certain extent in the near future, and definitely far into the future. And now, the hitting of the Earth, or the collision with Earth of an asteroid or a piece of an asteroid, is not at all very rare. I'm going to show you a report which is about a piece of an asteroid coming and exploding in the atmosphere in Russia in 2014. Please see this.
Collapsed walls, blown out windows, streets littered with shattered glass. The Russian city of Chelyabinsk cleans up after Friday's spectacular cosmic event. More than 20,000 workers are helping repair damage caused by the meteor. Seen as a fireball streaking above the Ural Mountains, it created a sonic boom. So powerful, it shattered an estimated 200,000 square meters of glass. The meteor was relatively small, just 17 meters in diameter, but it packed a punch and weighed about 10,000 tons. That's the equivalent of more than 4,000 Land Rover vehicles. It raced through the Earth's atmosphere at a staggering 54,000 kilometers an hour, or 15 kilometers a second.
Okay, so you saw that. Okay, a piece of an asteroid which is called as a meteoroid. That correspondent said meteor. Meteor is not the correct word. A small piece of an asteroid. Okay, I'll tell you what an asteroid later. Okay, so a small piece of an asteroid is called as a meteoroid. D for Delta, meteoroid. And if a meteoroid enters the Earth's atmosphere, and whatever fireball we see and whatever you saw in that report, that phenomenon is called as meteor. Okay, and excuse me, that space rock, if it survives its fiery entry in the Earth's atmosphere and falls like a rock on the surface of the Earth, it is called as a meteorite. T for tango. Okay, meteorite. Now, I'll define an asteroid, what it is, in fact. This is a picture of the solar system where the dominant body in the solar system, the sun, which contains 99.9% of the mass of the solar system, is there. And sun is being orbited by 8 large bodies, which we call as planets. Okay, and natural satellites of those planets revolve around those planets. Apart from these things, we have one more class of interesting bodies in the solar system called as comets, okay, which have their broomstick-like tails, in fact. But there is yet another group of bodies in the solar system called as asteroids. Why they are called as asteroids, I will tell you later. Most of the asteroids revolve around the sun in a so-called asteroid belt that lies between the orbits of Mars and Jupiter. This is the orbit of Mars and this is the orbit of Jupiter. In between that is the asteroid belt. But not all asteroids revolve around the sun in asteroid belt. They orbit the sun in different ways. Okay, so this is a picture depicting the solar system in a nutshell, in fact. And of course, there are 8 planets, 8 large bodies revolving around the sun, which we call as planets: Mercury, Venus, Earth, and Mars. And between the orbit of this Mars and Jupiter, asteroid belt is there. So, as I told you, the other 4 planets are gas giants. Of course, as I told you, one of the most interesting bodies in the solar system, and the dominant one, and the one which is responsible for all other bodies of the solar system revolving around it, is the sun. Okay, I'm not going to speak about it. That itself is a different subject. And moon. From the Earth, sun and moon appears to be of the same size for different reasons. Anyway, moon is yet another heavenly body which we see in our night sky and which is quite dominant as far as we are concerned. Okay, and of course, moon is a natural satellite of the Earth, and sun is a star, and Earth is a planet, and moon is a natural satellite of the Earth. And of course, I told you yet another class of bodies, comets. This is a beautiful comet. You can see it has got 2 tails. In fact, one is very clearly visible. And now let us come to asteroids. What are these asteroids? In fact, this is the classic case of an asteroid, probably Vesta, one of the asteroids, large asteroids, which is there. Okay, asteroids are small bodies. They look like the pieces of a planet. Okay, asteroids revolve around the sun mostly between the orbits of Mars and Jupiter. in a so-called asteroid belt. In fact, why are they called as asteroids? Asteroids means star-like. Let us go to history for some time. See, in 1801 on New Year's Day, okay, there was a priest who was also interested in astronomy, Italian priest, okay, Italian monk, okay, his name was Giuseppe Piazzi. He was looking for a planet, okay, he was looking for a planet between the orbits of Mars and Jupiter. So he was searching for such a planet in some region of the sky where he saw a slowly moving dot of light. Okay, slowly moving dot of light. That is, it changed its position in the sky over a period of time, very slowly. Okay, very tiny thing. Okay, so then when he saw this, of course, its orbit could not be calculated easily. But anyway, it came to be known that this object was orbiting the sun between the orbits of Mars and Jupiter. Okay. And 3 more objects were very quickly found, which were similar to this. That is, in the same way, they also moved, but they were all between the orbits of Mars and Jupiter. Okay, there was a genius mathematician by name Carl Friedrich Gauss. Okay, whatever information Piazzi had obtained by looking at these kind of objects in the sky from their position and change in their position, he could able to calculate the orbits. That was the genius of him, Gauss. Okay, so and these small bodies, these bodies which were found between the orbits of Mars and Jupiter, they were so small. See, earlier astronomers, when they looked at the planets through telescopes, planets which appear as dots of light, let us say Mercury or Venus or Mars, they expanded into globes. Okay, but again, when these 4 bodies were looked through telescopes, they appeared like dots of light only. They didn't expand into orbs, that is spheres. So like globes, they didn't look. So obviously the conclusion was that they were very small. Even in telescopes, they looked like stars. That is why they came to be known as asteroids. That means star-like. So this is the history of asteroids, and today we know that between the asteroid belt, between the orbits of Mars and Jupiter, we have more than 1.7 to 1.9, nearly 20 lakhs, let us say nearly 20 lakh asteroids with a diameter of more than 1 kilometer. In fact, they're in very large numbers. But let me caution you, all of them are not in asteroid belt. Not all of them. Look at that. This is the moon. This is once upon a time, this was called as the largest asteroid series. This is the one which Giuseppe Piazzi actually found on the New Year's Day in 1801, more than 200 years back. And probably this is Vesta. So this is much smaller. So most of the asteroids are only this series with the first asteroid to be found. Okay, this is about nearly 1,000 kilometers in diameter, and today it is classified as a dwarf planet also. For a long time, for example, one more thing is, look at the asteroids. They are not spherical except for Ceres. This is the largest asteroid and now called as a dwarf planet. This only is spherical. Most of the asteroids, they are irregular in shape. You can think of them as celestial potatoes, in fact. For a long time, astronomers were thinking that asteroids were the pieces of a planet that broke up or exploded. But today, astronomers are sure that asteroids are not the pieces of a planet that exploded due to collision or something. On the other hand, asteroids are the pieces of a would have been planet that never formed. Okay, that is the conclusion. Now look at yet another picture of asteroid belt. Roughly, this is the way asteroids are distributed. But I told you, all the asteroids do not revolve around the sun in asteroid belt. See, there are a group of asteroids which revolve around the sun in highly elliptical orbits. When they are very near to the sun, okay, the nearest point to the sun is called perihelion. It is within the orbit of the Earth. Look at that. This is the orbit of the Earth. And when they are very far from the sun, that is aphelion, actually is in the asteroid belt. So what are they doing? They are crossing the orbit of the Earth. Okay, they are dangerous asteroids. This is the kind of asteroid which came and hit the Earth 65 million years back and resulted in the death of dinosaurs, in fact. So these kind of asteroids with their aphelion in asteroid belt and perihelion within the orbit of the Earth, they are called as Apollo group of asteroids. Similarly, there is yet another group of asteroids. They too do not circle the sun in asteroid belt. Their aphelion is just beyond the orbit of the Earth. It doesn't extend up to Mars at all. Okay, just beyond the orbit of Mars, but their perihelion, nearest distance to the sun, is within the orbit of the Earth. They also cross the Earth orbit. They are also dangerous. Such asteroids are called A10 group of asteroids. And there is a third group of asteroids called Amors. Okay, Amor group of asteroids. Plural is Amors. Okay, so their aphelion lies in the asteroid belt, but the perihelion crosses the perihelion is within the orbit of Mars, but they don't touch the orbit of the Earth, but they come very near. Okay, they are also dangerous. So these asteroids which are not in the asteroid belt and they cross the orbit of the Earth or come very near to Earth, they are dangerous. So defending the Earth from them is one of the greatest challenges facing the humanity. Of course, that tomorrow, day after tomorrow, they will not come and hit big asteroids. There is a statistical possibility, okay? So, anyway, let us be ready. That is the philosophy. Of course, there are a lot of telescopes today which are active in monitoring the asteroid traffic in the in a region of the sky which is very near to the Earth. So such telescopes are tracking the so-called near-Earth objects which come within 5 million kilometers of the Earth. They are dangerous. Look at that. There are many radars which are tracking the asteroids. One of the asteroids was being imaged by an asteroid, and look at the Earth. Look at the picture, the way in which an asteroid sees a radar sees an asteroid. In fact, so you can track them and know many things about asteroids, but not all of them. Look at that. This is an animation of an asteroid. In fact, an asteroid like the Earth or the Moon or Mars, in addition to revolving around the sun, it revolves around its long axis. In fact, okay, that is the way. And you can see how in a irregular way it is spinning. It will not be that fast actually, but to make you understand, the picture is shown like this. So on October 4th, 1957, humans got the ability to launch something into space beyond the Earth's atmosphere and make it to revolve around the Earth or to travel to other bodies. The man-made object which was launched into space around the Earth, it was called as Sputnik 1, that heralded the space age. After that, many robotic spacecraft, not human-carrying spacecraft, robotic spacecraft have been launched towards asteroids, sometimes deliberately, and sometimes, though their objective was something else, on their way to their primary target, unmanned spacecraft or robotic spacecraft or automatic spacecraft, they have explored asteroids. For example, shown in this picture is Pioneer 10. Okay, Pioneer 10 was the first spacecraft to cross the asteroid belt. Many scientists were not sure about the density of the asteroidal population, as to how many asteroids were there and how close they were to each other. Statistically, they could not understand easily. So there was a lot of scare whether we would be able to cross the asteroid belt and travel to Jupiter, Saturn, Uranus, and Neptune. But anyway, such fears were dispelled by this Pioneer 10 spacecraft, which was the first to cross the asteroid belt, and its twin, Pioneer 11, also crossed the asteroid belt within a very short time. Okay, and there was no problem, and scientists they became sure that humans can safely cross the asteroid belt. Look at that. I'm going to show you a video. For example, this is the way a rocket is launched.
9, 8, 7, 6, 5, 4, 3, 2. Main engine start. 1, 0, and liftoff.
This is the way a rocket is launched. Just to break the monotony, I'm showing these kind of things. Look at that, the way in which the rocket is pitching. And, this is the way rockets are launched. And once they look at that, the way in which different strap-ons of so-called strap-ons of the rocket are firing, and how it is gaining speed. And after it achieves a particular speed, a rocket pushes the spacecraft actually into a region of the sky, and then it is navigated using the spacecraft's own propulsion system towards the asteroids. In fact. Now, let me show, okay, this is yet another launch, anyway, similar one. And this is a painting of the way in which Pioneer 10 actually from Earth, it started from the Earth and crossed the asteroid belt and went towards Jupiter. And Pioneer 10 was the first spacecraft to explore the Jupiter in 1973 or so. Okay, but the thing is, more importantly, it enlightened the humans about the fact that it is possible to cross the asteroid belt safely. And of course, Pioneer 10 and Pioneer 11, they are so far away. They say they are out of the solar system from one point of view. Okay, this is the way Pioneer 10 or Pioneer 11 looks. They are traveling in the opposite directions from the sun. In 1976, two spacecraft sent by NASA, they started orbiting Mars. They took the pictures of two small satellites of Mars, natural satellites of Mars called Phobos and Deimos. Many scientists say that Phobos and Deimos are almost captured asteroids by Mars, in fact. Probably when they ventured very near to Mars, they would have been captured by the gravity of Mars into orbit around itself. And this is Phobos. This is one celestial potato, maybe about 20-25 kilometers in diameter, the longest diameter, along the longest diameter. Look at that. Lots and lots of craters on that due to collisions. And this is the smaller of the celestial potato, smaller of the Martian satellite, Deimos. Okay, so this is the one. And these pictures were taken by NASA spacecraft Viking 1 or Viking 2. But what about your own spacecraft? See, you have to be proud, because your own spacecraft, not NASA spacecraft, your own spacecraft, which is dubbed as Mangalyaan or Mars Orbiter Mission spacecraft, it was officially called, has taken the picture of, this is Mars Orbiter Mission spacecraft, and it has taken the picture of Phobos. Look at that. This is the way Phobos is moving around Mars. From different frames, they have made this animation. Please try to understand, this picture was not taken by any other spacecraft. Your own spacecraft, Mars Orbiter Mission, has taken this picture. Look at the way Phobos moves. And the smaller of the second celestial potato, Deimos. This is also taken by Mars Orbiter spacecraft. See what wonders it has achieved. Anyway, that is required. About 2 hours are required for that. Suffice it to say, you people are listening to this lecture and many lectures given by others, by ISRO scientists. If your previous generation has done this, what prevents you from doing still greater things? Maybe landing on an asteroid, or helping the mining of an asteroid kind of thing, or sending humans to asteroid. Probably these are the things which you can think of. You are inspired by such lectures, not necessarily these lectures, such lectures, in fact. Now, let me tell you, Phobos and Deimos are thought to be the captured asteroids, I said, and your Mars Orbiter mission spacecraft also has taken pictures of them. But what about an asteroid, a real asteroid, that is the one in the asteroid belt itself? So that exploration began in 1991. In 1989, NASA launched a spacecraft called Galileo spacecraft, named after Galileo Galilei. Of course, he was the person who played a very crucial role in the progress of science, because he was the one who took a telescope and looked at the night sky, and actually he provided the proof for the Copernican system. Whatever Nicholas Copernicus told, the proof was provided by Galileo. But because of his advocacy of Copernican system, he actually invoked the wrath of the church at that time in Europe, and he had to suffer a lot. In his old age, he became blind even. Okay, but paradoxically, the spacecraft named after him also suffered a lot of difficulties. First, it was supposed to have been launched towards Jupiter directly by crossing the asteroid belt, but there was a problem after the Challenger explosion. One of the rocket which should have pushed it from Earth orbit towards Jupiter, that could not be allowed inside the space shuttle for safety reasons. I remember to have discussed it with Mr. Sundarmurthy at that time, 3 decades back. I still remember that. But anyway, another rocket was put, a solid rocket called inertial upper stage. And ultimately, this is the way Galileo spacecraft looked near Jupiter. Look at that. Its antenna could not deploy successfully. In this picture, you see this antenna like an folded umbrella. It is there. It should have gone like, it should have unfolded a plate or a dish, but it only deployed partially. That is why it could not talk properly to Earth. That is, the rate at which it could send the information was very tiny, but anyway, it was overcome. And look at that. And this is the launch of Galileo by the space shuttle. And that is the inertial upper stage, whatever I told you. Don't worry about the name. That is a solid rocket which was deemed as more safer. Okay. But when a smaller solid rocket instead of a big liquid rocket rocket stage was put, so Galileo had to take a circuitous route to Jupiter. And in that process, it actually explored 2 asteroids called, one of them was called Gaspra, the other one was called as Ida. Okay. In August 1991, Galileo crossed the asteroid belt, and at that time, it went a few thousand kilometers away. It passed by a few thousand kilometers from the asteroid Gaspra. Gaspra is about 18 to 20 kilometers in diameter, like a potato, as I told you. And you know what kind of an asteroid it is. Let me tell you one thing. As far as asteroids are concerned, scientists classify them into S-type, M-type, or C-type. S means siliceous, that is silicates, okay? Rocks predominate in those asteroids. M-type means metallic type asteroids. So in them, nickel and iron and nickel, they predominate, okay? They are the major things present. And C-type is called as carbonaceous or chondrites. Don't worry about it. Mostly they are carbon, okay? Carbon is there in them. That is why they are very dark. But then Gaspra is what kind of an asteroid it is, okay? It is an S type of asteroid that is containing silicates. This is about 18 to 20 kilometers. And all these, many of these asteroids revolve around their axis once in 10 to 15 hours within that. Okay, look at that. And this is the first picture of a real asteroid taken by any spacecraft. Okay. Next, 2 years later, Galileo passed near yet another asteroid called Ida. Okay. So this is the asteroid Ida. But the fantastic thing is they found out one thing. Ida has got a satellite. First of all, asteroid itself looks like a small piece of a planet. And for this, there is a satellite. Okay, when the photograph date, it was at a distance of only about 90 kilometers or something like that. This IDA's satellite is called Dactyl. Okay, so this is only 1.4 kilometers in diameter. What a wonderful thing. In universe, in our own solar system, these kind of things are there. Nobody had photographed. If somebody were to think also, nobody would have photographed. This is the way it was. Ida is also an S type of asteroid. It is about 52 kilometers in diameter. And again, as I told you, within 15 hours only, it was spinning around its axis. And look at that. This is an animation of Ida from different perspectives, how it looks. That is the thing. Then, in 1996, NASA deliberately launched a spacecraft towards an asteroid called Eros, E-R-O-S, Eros, named after the erotic god of ancient Greece. Okay, so this, please remember, Gaspra and Ida, the first two asteroids explored by any spacecraft, they are in the asteroid belt. But NASA launched a spacecraft called Near Earth Asteroid Rendezvous, that is meeting an asteroid, near Earth asteroid. So it is a near Earth asteroid means, so it is an Amor group of asteroids. That is Amor group of asteroids, I told you, their aphelion is outside the orbit of the Earth. The perihelion is inside the orbit of the Earth. They cross the orbit of the Earth. That's why they are dangerous, I told you. So this Eros belongs to Amor group. This is the Near spacecraft. It was launched in 1996, and this is the way it was launched. And on the way, it photographed a main group of asteroids within the asteroid belt called Mathilde. Don't worry about these names. There are so many names which we can't even understand and pronounce. Okay, anyway, because of repeated reading, I know Mathilde. Okay, this is all ancient Greek or Roman names. Okay. This is a C type of asteroid. Only in this enhanced picture, you will see it bright. Otherwise, it was very dark, in fact. This is also about 50 to 55 kilometers in diameter, but it was spinning around its axis very slowly, in fact. And this was the target asteroid called Eros, okay, erotic god. See, Americans, everything, they do it colorfully. And this is the Eros asteroid. First, in 2000, they made it to revolve around the Eros asteroid on the Valentine's Day. Okay, look at the way they have chosen this. Okay, and ultimately, they slowly settled it down on the surface of Eros asteroid, in fact. Okay, they spectroscopically, they studied it. And of course, this Near spacecraft became the first spacecraft to land on an asteroid. It is not easy to land on a smaller body. It is relatively easy to land on a planet, not on an asteroid or a comet. And look at that. After the America, it was the turn of Japan. Okay, in Japan, after the Second World, during and even after the Second World War, there was a great scientist, rocket scientist by name Hideo Itokawa. In fact, he played a somewhat an important role in the Indian space program also. He was hired as a consultant by Dr. Vikram Sarabhai during Tumba days. And Hideo Itokawa was a scientist, and an asteroid which was discovered in 1998 was named Itokawa by Japanese. This is that asteroid. This is an Apollo group of asteroids, okay? It's aphelion, the farthest point from the sun, lies in asteroid belt, and its perihelion, nearest point to sun, lies within the orbit of Earth. So it is dangerous. Okay, so this was the one, and this asteroid is, very small asteroid. At the most, the thing is, it is about 500 meters, less than half a kilometer in diameter. Okay, and this is a S type of asteroid. Once in 12 hours, it was circling the Earth, and it circles the sun once in 1.52 years. Look at this. This is the way the spacecraft called Hayabusa, okay, it went and explored Itokawa. At that time, when I came to know the name of the spacecraft was Hayabusa, I was mentioning it to my son who was in high school or something. And when I say Hayabusa, I thought it was only the name of the spacecraft. He said Hayabusa with a lot of excitement. Then I didn't know why. Then I came to know that it is the name of a peregrine falcon in Japanese, okay, Japanese language. And more than that, even why small school children also know about it. You see, this is the name of a Suzuki bike called Hayabusa. Okay, that is why even children were knowing. But the spacecraft which explored Itokawa asteroid is Hayabusa. It is called peregrine falcon. Okay, falcon. That is the thing. This spacecraft was launched in 2004 or something. It is it was launched and it went to Itokawa, a type of asteroid, and it explored it, collected the soil and rock samples from that asteroid, and it experienced some difficulty and brought back to Earth those precious samples. You can see the way in which the capsule is re-entering, and this is the capsule. They have put it in a museum which carried, say, very less, a few grains of rock and soil from the asteroid Itokawa. And now Japan launched one more spacecraft called Hayabusa 2. Okay, Hayabusa 2. And this time they sent into yet another near-Earth asteroid called Ryugu. Okay, Ryugu. Okay, that is the name of the asteroid. And this asteroid is about 1 kilometer in diameter. Look at that. It looks like a rhombus kind of thing in this picture. And a lot of boulders are there. And many people were calling it as a rubble pile also. Okay, so this is the thing, and this is the way it looks from 360 degrees. And look at this spacecraft Hayabusa 2. It went to the asteroid Ryugu in 2018, and look at that, the way in which it went and it started circling the asteroid. It is not easy to put it into an orbit around the asteroid also. Of course, the spacecraft later actually, look at that, how it collected the soil samples from the asteroid, and it brought back those samples to Earth in 2020, about 5 grams of asteroidal soil and rock samples. Look at that. This is the way the surface of the asteroid looked to Hayabusa 2. Look at the boulders, the way in which can you believe these are the things which have happened? And not to be undone, not to be neglected, Americans, they had one more program called OSIRIS-REx. That's a very big name, you will not remember. Okay, so that is the name of the spacecraft. It went to a near-Earth asteroid called Bennu. Okay, Bennu is a mythological bird of ancient Egypt. They named this asteroid after that bird. And this asteroid is about 500 meters in diameter, very small, 500 meters, less than 1 kilometer, like Itokawa. Okay, that's the way it is. And this OSIRIS-REx spacecraft, it went near this Bennu, and very patiently it was put into an orbit around that asteroid. And look at that. Ultimately, it neared that asteroid, and of course, it collected soil and rock samples, and very precious ones. Why these are important, I will tell you about it. Okay, why rock and soil samples from asteroids are very important, I'll tell you. And look at that. This is the surface of an asteroid, strewn with boulders. It was very difficult for the spacecraft to land on the asteroid. And look at that. This is the way. Just I will show you some animation. You will
In
better
December
understand.
2018, after traveling for 2 years, 101 days.
Look at that. See, this is the way OSIRIS-REx spacecraft started revolving around Bennu asteroid, and look at that, the way in which it approached the surface. Yes, nitrogen gas was blown and a lot of debris came up and it got sucked into the mechanism, and the spacecraft collected that. And on this September 23rd, less than 2 months back, it has brought back those precious samples back to Earth. Okay, so this is the way asteroidal exploration is progressing. And so much so about collecting the precious samples from the asteroids. Now, let me talk to you about yet another spacecraft called Dawn, D-A-W-N, Dawn. This was a NASA spacecraft that was launched with the objective of studying 2 asteroids in the asteroid belt. Both of them were the first asteroids, very few first asteroids to be discovered. Shown in this picture is the Ceres, C-E-R-E-S, Ceres, the largest asteroid, which is about 1,000 kilometers in diameter. Of course, it is also called as a dwarf planet now. So this spacecraft went to Ceres at a snail's pace, very, very slowly using its ion engine. And before that, look at that, the way in which it went, Dawn spacecraft. Okay. So it is like interplanetary billiards. That is the way it took advantage of the gravity of the Earth, not once, twice. And using it as a slingshot, it explored 2 asteroids in the asteroid belt. First, it was Vesta, and the other one was Ceres, as I showed you that picture. This is Vesta. What did we learn from this? Okay. Now, scientists are sure that this Vesta asteroid, which is perhaps the 3rd largest or something, with 535 or so 500 plus kilometer diameter, okay, it is well differentiated. Like the Earth, it has got a crust and a mantle, that kind of thing it is. That was not known, and spectroscopically also they have studied the composition of Vesta, and look at that, the craters and all those things. Then after studying Vesta between 2011 and 10 and 12, in 2015, it was the Dawn spacecraft was sent to Ceres and explored it for the yet another. So, okay, and you see what is known today about Ceres is it has got a watery ocean, salty ocean below its solid surface, icy surface. You have to understand these things. From the surface of the Earth, we can't know all these things. But if a spacecraft is sent very near to it or to land it on its surface, then it can study and it can provide you the correct and exact information. That is how science progresses. Now, studying asteroid is one thing. Okay, asteroids are studied because of many reasons. I will tell you a little bit later. In the next 5 minutes or so, I'm going to finish the lecture. But last September, 2022 September, okay, a NASA spacecraft called DART, Double Asteroid Redirection Test. It went near a near-Earth asteroid called Didymos. This is a larger asteroid called Didymos, okay? This larger asteroid is being orbited by a smaller asteroid called Dimorphos and Didymos. What they did was, they sent this spacecraft and near Dimorphos, not Didymos, Dimorphos, and hit it deliberately at a very high speed. What is the reason? They wanted to see as to, by hitting that asteroid, which is very small, maybe about 200 meters or so, less than that, okay, whether they can reduce the velocity of its orbit, velocity in its orbit around Didymos. They tested it. Why did they test? Tomorrow, if we want to deflect an asteroid that is going to threaten the Earth in the future, you can just nudge it a little bit away by hitting it. Okay? And over a period of time, its path diverges quite a bit and it will miss the Earth. This is what they wanted to test in a preliminary way. So to defend the Earth from asteroidal attack and the catastrophe that ensues. So this was a very successful test, and indeed the speed in its orbit around Didymos has significantly reduced as far as Dimorphos is concerned. And my dear friends, one more thing. I told you studying the asteroids are very important, especially their surface, their strength and all those things. Because when you hit an asteroid, if it is like a single body, it is okay. If it is not a single body or instead of that, if it is a rubble pile, if you go and hit it, then it gives rise to lots of pieces. All of them may come and hit the Earth. So your entire purpose will be defeated. That's why before you go and hit an asteroid, you have to know its composition, its strength and other things. That is what is inferred, that is known by studying the asteroidal material brought back by Hayabusa 1, Hayabusa 2, and now Osiris-Rex. So this is the thing. And now this is the way I want to show you the video. This is very exciting of double asteroid redirection test. Look at that. This was the way DART spacecraft was launched. It unfolded its solar panels and it went near Didymos-Dimorphos pair by traveling millions of kilometers away. And look at that. It went and hit Dimorphos. You see, that is Didymos and it is being orbited by Dimorphos. Okay, this spacecraft met Didymos-Dimorphos pair, and look at that. It is its ion engine, and it put a spacecraft out to take the pictures of its suicidal mission, and you can see the spacecraft going and hitting Dimorphos, the smaller one. Look at that. Yeah, this is the way it was in its crosshairs, and the spacecraft went and hit Dimorphos and it changed its orbit. So it is a success. So you can be happy. And now we have two NASA spacecraft which are going towards different asteroids. One of them is called Lucy. Lucy, many of you may know, that was the name of a hominin fossil, human fossil, which was found in 1974 by a paleoanthropologist called Donald Johanson. And now this Lucy spacecraft launched by NASA in 2021 is going to study an asteroid in the asteroid belt called Donald Johanson, named after that gentleman, that scientist. And later it will go to the orbit of Jupiter. And just ahead of Jupiter and behind the Jupiter, there are a group of asteroids called Trojan asteroids. And as I told you, all asteroids are not in asteroid belt. You remember that. And these Trojan asteroids are quite different from other asteroids, and they are being studied by Lucy spacecraft in 2027 and 2034. Okay. And very recently, a few weeks back, NASA launched yet another spacecraft called Psyche. I told you, Psyche, Psyche. This is going to study an asteroid in the asteroid belt called 16 Psyche. Psyche, that is the name of the asteroid. Why this is important? Because this is a metallic asteroid. Mostly it is nickel and iron, but it has lots of gold. That's what people say. One day humans may go and make trillions of dollars. Okay, it is worth trillions of dollars. Maybe a lot of people, if they go and without quarreling, if they can mine it, maybe they get billions of dollars. I don't know how the world will be at that time. Anyway, this is the preliminary step in studying such asteroids. The spacecraft is already on its way. And already a lot of spacecraft orbiting the Earth are studying near-Earth asteroids because they pose a danger to us. Okay, this is one spacecraft called WISE spacecraft. Okay, and this is yet another spacecraft going near an asteroid using a solar sail. And this is yet another spacecraft which will be launched in 2027 by NASA to study near-Earth asteroids, to know their orbits, their number, their characteristics, and such things. And why do we study asteroids? Next 2 minutes, I will tell you very quickly. Why do we study asteroids? Because one thing is, asteroids are like fossils which tell the story, which provide us the story of the origin and evolution of the solar system. Because it is from asteroid-like bodies called planetesimals that planets were formed. Thus, to know the origin and evolution of the solar system, the study of asteroids is important. Similarly, asteroids have been known to contain chemicals which are precursors of life, not life-bearing chemicals, but they contain chemicals which are essential for life. So there is a theory called panspermia, whether life was brought to Earth or life-bearing chemicals or chemicals found in life forms were brought to Earth by asteroid kind of bodies. Nobody knows for sure, but asteroids contain them. To know more about the origin of life on the Earth, study of asteroids is important. Third thing is, asteroids contain minerals and many other materials which are essential for our industrial civilization. So exploitation of asteroids is now being seriously considered already as part of the growing space economy. And fourth one, as I told you, near-Earth asteroids pose a danger to Earth. Already they are not once, at least as we know, for sure, for the most part, they were responsible for the destruction of the dinosaur species, in fact, decimation of them. So that's why in order to defend our planet from such attacks, we have to study the asteroids. These are the four main reasons for studying of asteroids. And this is the picture of a spacecraft landed on an asteroid. In fact, you see the way in which astronauts are floating in the low gravity. If you have a few meters of speed, you can escape from an asteroid. But the escape velocity of the Earth is 40,000 kilometers or 11.2 kilometers per second. But due to their smaller mass and smaller diameter, asteroids have very less gravity. That is why it is not easy to put a spacecraft into an orbit around them. You can see an astronaut here, astronaut or a cosmonaut or a vyomonaut or a taikonaut, whatever you call. So exploring an asteroid or trying to find out the kind of minerals and such things. This is a futuristic photograph, a painting. And, look at the history of the space exploration. Look at the way how astronauts are hopping like kangaroos on the surface of the moon. Humans, the conquest of the moon by humans was in 1969. Between 1969 and 72, 12 people have walked on the moon and we have conquered the moon. So this is the picture of Edwin Aldrin. The picture is taken by Neil Armstrong. This is Edwin Aldrin, not Neil Armstrong. So looking back at the success of humans in exploring space, so it makes us optimistic about the further exploration of asteroids and our growing capability to defend the Earth from rogue asteroids that threaten humanity on the surface of the Earth. So thank you very much. With that optimistic note, I have finished my talk today. Once again, my thanks to E.K. Kutty sir for this opportunity. Thank you very much. Yes, dinosaurs. Please, sir.
And thank you very much, Sajid. Guruprasad, I think he is the best communicator, science communicator I've seen in the recent times from ISRO. Okay, I know him from last 30, 40 years now. One of the most important thing what I do believe is collecting all the information available from the literature yesterday, today, and what will happen tomorrow, putting them together in a story fashion and telling the children in some art itself. Of course, some of the questions to be asked by the students may be really perplexing for you, but I think this triggers the imagination of the students. And of course, you talked about the various types of asteroids, including you started ending with the Trojan asteroids. I was wondering why you're missing the Trojan asteroids. Very, very important because they're all in the Lagrange orbits, L4, L5. I thought you'll definitely mention them. And of course, Psyche is another important thing. Psyche is a core metallic study of those asteroids. Will throw light on our own Earth's core subject. Core of the Earth is supposed metallic. It is covered by a lot of gaseous and gaseous and carbonaceous material. How the Earth evolved itself will be probably known from asteroid study. All these things are very important. I'm sure that the future is exciting for those technology-oriented people. On the one side, you can see putting a satellite around an asteroid is not an easy job. Billions of kilometers away, a small element, orbit is not easily predictable, and you put it in and landing on an instrument on that and beginning of and all the way back to the precise location. I do remember exactly the Hayabusa 1 and Hayabusa 2 when it began, and we talked about fantastic capture of that material. I think there are technology involved, there are instrumentation involved, magnetometer, spectrometer, you name it, all that you talked about. I think you covered exactly all the elements involved. I'm sure the students will have got benefited. Thank you, Dr. Guruprasad, and also Mr. Kutty and Saji for inviting me to attend this particular meeting. I'm very good. Thank you very much.
Thanks a lot, sir. You have seen me like a kid in ISRO. To get such accolades from you, I'm really blessed. Thank you very much, sir. Yeah. I think it is 5:30 in the morning for him.
Yeah. Thank you so much for giving me an opportunity to listen such a rather wonderful lecture from Guruprasad. I know Guruprasad. Okay, as Jaraman sir has told, we were together and then we were discussing many things. In fact, few years back, someone was asking me about this asteroid mining. They wanted some kind of a brief note kind of a thing. Then I started searching and then I tried to get some of those things. But by listening today's lecture by Guruprasad, I've not even done justice to that, not even 1% of whatever Guruprasad has told. I could not get it. But anyway, now it is a very good thing for the students to learn things like what in olden days, like in our 1969 when a moon, the Neil Armstrong landed on the moon. It has created a big furor and interest among the scientific communities. In those days, I was in my school days, I think. So like that, now it is the period where now we are looking for asteroids. I think this is going to be the next bigger thing which is going to come. I'm thankful to Kutisap and Sajil, all other people. Okay, still I'm keeping in touch with the subjects because of these kind of lectures and other things. Okay, all the best for the students. I don't want to stand in the way. Thanks, Guruprasad.
Guru, I thought I should tell you something more. I know, you know, but the Star Trek serial.
Correct, sir. Yes.
The Star Trek serial, you would have heard about the Mr. Spock, the cat.
Yeah.
One of these asteroids is named after Spock.
Yeah.
You know, the naming of asteroids is all funny. Even a rock musician, name is put for an asteroid.
Yeah.
Even on those 7 astronauts who died in the Columbia shuttle disaster, all the names are given to asteroids. So asteroid names are given randomly by people. Maybe tomorrow there will be Guruprasad asteroid also. Thank you.
No, sir. Yeah, correct. That, as you said, Mr. Spark, that was, I mean, that role was played by Leonard Nimoy. He is the man who after whom it is named. Nice, sir. Vikram, sir. Oh, okay. Okay, and the moon craters, they are different. Okay. Thank you, sir. Thank you.
I think Madan Gopal also, Madan Gopal also should be able to comment on this talk.
Yeah, I think Guru is always Guru. I always tell he's Guru only. Great Guru. Fantastic talk.
Yeah.
And really so enlightening and educating to all of us. I feel students certainly might have got motivated. But this triggered in me one more curiosity. We are going to a lot of asteroids, going to planets, all those things. But we are not trying to explore core of the earth by a mission like that. Why not we think? I was thinking like that. Because we are trying to find out from outside how the core or how the interior earth is made. We are not able to go beyond 15 kilometers. Maybe mankind should find out some new devices, new things so that at least we may go up to 5,000 kilometers. It came to my mind, of course. That's all. Thank you, Guru. Wonderful talk.
Yeah. Thanks a lot, Ganesh Rajji. See, the thing is that Jayaraman sir was telling, the Psyche asteroid is a metallic asteroid. They think that either it is an asteroid whose, mantle and such things have been worn out and only the core is exposed, or actually due to collision, probably that would have been the case, or during the formation itself, it was like that and other things have not accumulated the other way. So different interpretations are there. So
Guru, I'm not telling that way.
No.
Metallic. I'm telling when the high temperature pressure, the core, so much high temperature pressure, you are not able to bear. You're not able to go inside.
Correct.
I'm telling that way. Some vessel, some spaceship type, like Earth ship, if you are able to develop, which can withstand high temperature pressure, go up to the core, it will be wonderful.
Sir, Ganesh Raj, you are talking about going to the core.
Yeah.
I'm sure you know very well than me. The surface of the ocean, they don't know much. Surface of the moon, they know more about compared to the surface of our oceans. In fact, Mariana Trench, which is where it is near on the crust itself, it is there. And you are going to core.
Samudran is planned. We have got depth of 10 kilometers. I agree.
Yeah.
Actually, for the your talk made me to think like that, Guru.
Yeah. So you can give a talk on that. Yeah. Thank you. Yeah.
Thank you, sir. I think you can listen now.
Yeah, you can.
It was a very wonderful lecture, and it has created a spark to young minds. So I think they'll further pursue from this knowledge on asteroids, meteoroids, or any astronomical bodies. So his lecture, anyway, we are often interacting with Guruprasad and knowing each other and benefiting in science and technology and all. Thank you very much and all the best.
Thank you. Yeah.
Yes, sir. Am I audible? Okay, good evening, everyone. I'm Devananda Srijit. I'm studying in 8th standard and I'm from Bhavans Vidyashram, Chelembra. And I'm honored to be a part of the US Space Club. And today I'll be hosting the question answer session. So, first of all, I request everyone to please type their questions in the chat box along with their name and class. And one by one, I'll be reading them out, and accordingly, sir, please answer the questions.
Sure. Please. I'll do it to the best of my ability.
Okay, sir. So we do have questions now.
Yeah.
The first question is by Adidev of 7th grade. And
Yeah.
he's asking that some asteroids in the presentation that you showed were diamond shaped. And he's asking whether there is any reason as to their unique shape.
See, asteroids basically, most for all practical purposes, most of them are of irregular shape. Because, these asteroids, when they were formed, probably they were formed due to the collision of other larger bodies. So, and when such things result in, so irregular shape will be there. And another important thing is, you may ask why planets and their satellites, many of them, larger satellites, they are spherical in shape. Why not asteroids, in fact? And irregular shapes, there is any reason? One thing is, due to collision, they have been generated like that and they have not changed. The other thing is, they don't have sufficient mass to get themselves compressed in the way that is for the minimum volume, okay, they have to take. So that is actually the spherical shape. If you don't have sufficient mass, you will not achieve spherical shape, okay? But only exception is that Ceres, okay, which is the largest asteroid. Because of their very low mass compared to that of the planets, okay? And due to the way in which they are generated, so they have that kind of shapes, diamond, irregular, like potatoes and such things. Yes.
Okay, Adil. So I hope sir has answered your question.
I hope I have answered. Did you understand that? See, you break a coconut also, the way in which, unless you break it very expertly, it will be in pieces of different shapes and sizes,
Yes,
isn't it? In fact, that is the way. That is one answer. The other one is, I told you, small mass, so that they cannot achieve the spherical shape. Okay? Some critical mass is required for that. Okay? Only large, even planetary satellites which are small, they look like potatoes, in fact. Okay? Very small ones. Next.
All right, sir. May I move on to the next question?
Yeah.
Hello, sir.
What is the next question?
Okay, the next question is by an account from Akhila. Please mention your name and class. The person is asking whether nitrogen gas is used to collect sample from the asteroid by blowing the gas on its surface. And is there a particular reason for using that particular gas?
Yeah, nitrogen is quite inert, isn't it? Okay, am I correct? See, whatever gas you blow, it should not react with the samples which you are collecting. And it should not lead to something else. The composition, you should not read it wrongly. So that is why nitrogen gas was used. That is one of the reasons. Okay. Next one, please.
Yes, sir. The
It
next
should not be
question
highly
is-
reactive. The gas which you blow should not be active, very reactive. Okay. Next.
Sir, the next question is asked by Nandana P from 9th standard. How can the study of asteroids help us learn more about the origins of life and the potential for life on other celestial bodies?
Yeah. See, this is a very good question. Let me tell you. As per the current understanding, the thing is, the solar system was formed like this. This is the way. There was a giant cloud of gas and dust, it seems. Not cloud means not the rainy clouds which we see in the sky. Gigantic clouds, okay? We can't even imagine. Okay, giant cloud there in our Milky Way galaxy, in one small corner, there was a giant cloud of gas and dust. And due to some reason, it started collapsing onto itself. It started getting compressed onto itself. It started collapsed onto itself. And the central portion became the sun. Okay. And slowly from the gas and dust, that cloud of gas and dust surrounding the sun, actually, smaller bodies, which are like asteroids, called planetesimals, I told you during the course of my lecture, they were formed. And these planetesimals in turn came together and collided with each other, stuck to each other, and they ultimately formed the planets. So that is the way our origin and evolution of solar system is being thought of today. So if you are able to study the materials from which your planets are made, so you will better understand the origin and evolution of the solar system, isn't it? So that is why the study of the asteroids help us understand the way in which asteroids or planetesimals came together and formed the planets like Earth. That is the reason why it is very important for us. Any other question?
So the next question is
Yeah.
by Adil Prajesh
Yeah.
of 7th standard. And he's asking, if an asteroid comes to our Earth and they are burned in the atmosphere, then they disappear. And where did the matter of asteroid, where will the matter of asteroid go?
It won't go anywhere. It will be dispersed in the Earth's atmosphere because Earth's gravity is there. It cannot, if it explodes in the atmosphere with tremendous speed, let us say, okay, tremendous, if there is a tremendous explosion of the asteroid in the atmosphere itself, probably some of the pieces may go outside the Earth's atmosphere, but many of them, they will come down and rain on the Earth itself. If it is too small a particle like dust, it gets scattered in the atmosphere. I showed you a picture of dinosaurs, rocks are raining down on them, in fact. Okay, they are the pieces of the asteroid that exploded in the air itself. Apart from that, whatever due to the impact, whatever rocks got ejected from the surface of the Earth, they too fell back. Okay, so what happens to, if an asteroid explodes in the air, what happens to the material? Either it gets circulated in the atmosphere, or if bigger pieces are there, they may fall to Earth, or some of them, depending on the direction and the way in which explosion happened, they may go outside the Earth's atmosphere, depending on the speed also. Okay. Next.
Okay, so next, Janna Jamila has asked that different asteroids have different names, and who names these asteroids, or why do they have that name?
Yeah, the thing is, the series Pallas, Juno, Vesta, these were the first 4 asteroids. So it was named after the agricultural goddess of Sicily and such agricultural goddess and goddess of Sicily, like that, Giuseppe Piazzi, the man who discovered the very first asteroid series. This one. Nowadays, asteroids are named after, the thing is, mythical bird of ancient Egypt, like that, and names of the persons also, like Hideo Itokawa, like that. So actually, there is a organization called International Astronomical Union. Okay, related to that, there is an office in Boston, in the United States, and there, Bureau of Astronomical Telegrams or something like that. there people have to register, and based on the acceptance and such things, names of the asteroids ultimately they come, in fact. So names are there of persons, names are there of mythical things, so such things. But very first asteroids were named like Roman and Greek goddess, something like that. Okay, this is the way.
So next question is by Abhinand Krishna of 8th standard.
Yeah.
He's asking that you said that asteroids can also carry coal inside them, but he's asking how coal can even form in such harsh
Where
conditions.
I didn't say coal is inside them. No, I have not told. No, it's a mistaken thing.
Okay, sir. It
Coal
might
is
be a
nothing but
misunderstanding.
carbon, no? Carbon only, no? Okay. I don't know whether in the form of, see, there are 3 different types of asteroids I told you. One is siliceous asteroids, silicates. Second one is metal type of asteroids, M type of asteroids. Third one is carbonaceous asteroids. Both coal, graphite, diamond, okay, they all contain carbon, okay. But the thing is, I never said that coal is there inside the asteroids. No, they contain carbon, they said.
Did you say gold or gold?
Huh?
Did you say
Gold,
gold?
is it? Gold. Oh, I'm sorry. I heard it wrong. Okay. Gold, yes. Probably, the thing is, gold is not formed in asteroids due to asteroid forming process. As astronomers say, things like gold can be formed only in supernova explosions. In fact, only up to iron stars can form, let us say, elements up to iron only. But beyond iron, if you want to form, only one source is supernova explosion. Probably whatever supernova explosion was there sometime back, that material also got assimilated into the material which formed solar system. That is how that might have been accumulated in the asteroids. Asteroids themselves have not formed gold due to their formation. No.
Okay, sir. Thank you. Next question is by Harigovind of class 12th. And he's asking that asteroids are self-rotating like other planets. And what makes them rotate as they go through space?
What makes Earth to rotate? What makes Sun to rotate? Okay. The cloud from which Sun and other planets were formed, already it had some rotation. Okay. Nothing is actually static. Okay. It was moving in some way, but when it got compressed onto itself, its angular velocity got increased, in fact. Okay. Angular momentum is conserved, not angular velocity. Okay. That kind of thing. So asteroids are, I told you, either many asteroids are formed by the breakup of much larger bodies, not the breakup of a single planet, breakup of much larger bodies. So the way in which it breaks up, probably that may induce some rotation into it. Okay, that is the reason why. And over a period of time, very, very, very slowly, not 100 years, 200 years, over millions or hundreds of millions of years, due to many things, including sunlight and such things, slowly asteroids, and to a certain extent, the gravity also of other nearby bodies, the rotation of the asteroids may be influenced by that. Okay, that's the way. Very good questions, really thought-provoking questions for me. Okay.
Thank you. Next question is by Ashira of class 9. And she's asking that we all have seen a beautiful space event recently called Perseus meteor shower. What is the science behind this beauty? And do they have any connection with asteroids?
No. Perseid meteor showers, the thing is, they come from the direction of the constellation of Perseus. Okay. Meteor shower. Okay. Normally, every day you can see meteors. But normally what happens when a cometary dust or the small pieces of a comet, okay, when it pass near the Earth or near in the inner solar system, when the Earth passes through that, okay, so they come in relatively large numbers, and that is how instead of single or a few meteors, you have a shower of meteor. Okay, probably they are of cometary origin. I doubt very much they are of asteroidal origin. In fact, but you know, asteroids and comets, their pieces together, I said, it is known as meteoroids. So these Perseid meteor shower is nothing but meteoroids coming from the direction of Perseus. Maybe some of the pieces of asteroids also may be there, but many of the cometary showers are associated with the pieces of the comets. Okay, that is the kind of thing. That's a beautiful phenomenon, no doubt. Instead of 2-3 meteors in an hour, you may get 15 to 20 meteors you can see. Let me tell you, meteor is a phenomenon. Meteoroid is the one which enters the Earth's atmosphere. If it survives and falls on the ground, it is meteorite. Okay?
Okay,
Next.
sir. Next question is by Bhavya Ravindran of class 10. And she's asking that she would like to know about the asteroids Apophis, which is estimated to hit the Earth in 2029. And would there be any precautions for that?
Yeah, a very interesting question. You know, the thing is, one of this American spacecraft, OSIRIS-REx, which brought back samples from Bennu. Now it is redirected towards Apophis asteroid to study it. But anyway, let her not worry. Let her or him not worry. Now they have revised 2029, 2036, and all those years. Apophis is not going to collide with the Earth. Okay, it will not hit the Earth. They have refined the orbit over a period of time. Okay.
Yes, sir. The next question is again from Adidev of 7th, and he's asking whether ISRO would launch a mission to asteroids similar to NASA's Psyche or Lucy.
See, that ISRO people only have to answer this question. Okay. The thing is, I'm no longer with ISRO. I cannot make a statement on that, but I don't want to disappoint you. Obviously, there were studies, I understand, conducted about the exploration of asteroids. Now, already we have explored the moon, the Mars, and such things. And of course, we are studying the sun. Maybe in future, as a result of the studies, and mind it, a study is only trying to understand the pros and cons of going there. And a project is different. Once a project is formed, you are pursuing it. So still it may take time, and I think, okay, well and good. I think with their experience of exploring the planets, planet Mars and Moon is also Moon also can be considered as a planet from the point of view of size, though it is the satellite of the Earth. It is a planetary body. It is classified, said like that. So with their experience of exploring Moon and Mars successfully, nothing prevents ISRO from exploring asteroids if they deem it necessary. Thank you.
Yes, sir. Thank you. And the next question is by Navni P of 8th standard. Her question is that, given the recent advancements in asteroid exploration, particularly with missions like Hera and Psyche, what potential breakthroughs or discoveries do you anticipate in the near future that could significantly contribute to our understanding of asteroids and their impact on planetary formation?
See, on all the aspects, I told you, why asteroids are important. One is to know the origin of the solar. One is to further understand in detail the origin and evolution of the solar system. As you study more and more asteroids, you will come to know more and more things, curious things. On that front also, you are going to have a lot of advancement. And by studying more and more asteroids, you will know more about you will know more about the way in which asteroids would have influenced the origin of life on the Earth. Okay, their contribution to that. Third thing is by spectroscopically studying the asteroids, that is, what is their chemical composition, mineralogical composition, and elemental composition, and how much is there, the quantum of that, probably you will be able to get some view on the way in which we can exploit them. That is the third thing. Fourth thing is by studying the asteroids more, probably we will be more successful in future if Earth is threatened by an asteroid, like you said, Apophis earlier. Okay, now it is, that threat is not there. So on all four fronts, definitely we are going to get advancement, especially, as Jairaman sir was telling, there is a new group of asteroids. New means such asteroids have not been studied at all. They are known as Trojan asteroids. They are not in the asteroid belt. They don't come near the Earth, but they share the orbit of Jupiter around the Sun.
Yes, sir. And the next question is by Prayan of 4th standard. And he's asking if there is any chance to terraform asteroids and make any life forms on the asteroids.
No, I'm sorry, I didn't get it. Can you slowly tell me?
Yes, sir. He's asking whether there is any chance to transform asteroids into a place where life can be formed.
Okay, I told you, the thing is still we are trying to understand whether precursors to life or chemicals which are part of life were brought to Earth by asteroids. Okay, just by taking asteroids somewhere, some conducive, that is proper environment, and making life forms with their help, I think it is too science fiction as of now. I don't foresee that kind of thing in the future, near future, I will say. But anyway, good idea, maybe.
Yes, sir. And he also has another question. He's asking, what can we do to stop an asteroid which has boulders from hitting the Earth?
No, yeah, very good question. Okay, this is still being studied. If it has got boulders and it is only a rubble pile, means you have to very, very, very carefully approach that asteroid. Okay, I'll answer this. So instead of breaking that asteroid, okay, breaking up is not possible because, it leads to a lot of stones, boulders kind of things, which may ultimately come and hit. Boulders means not small boulders, very large ones, okay? That kind of thing. Only thing is you have to study the asteroid and you have to see and select a proper point and use, okay, a rocket engine kind of thing. Maybe in the future, not the kind of rocket engines we have. Not going and hitting. You can attach something, okay, and just push it away a little bit, not too much, a little bit. Push it. If the asteroid is going, chances of asteroid hitting the Earth is after 10 years, even a little push over a period of time make the asteroid to go away from the Earth. So that strategy may work, that kind of thing, instead of hitting it and breaking it.
Okay, sir. The next question is by Sudev of 10th standard, and he's asking why asteroid belt is situated between the orbits of Mars and Jupiter.
Oh, philosophical question for me. Okay, I would answer like this as far as my understanding goes. Okay, probably by chance occurrence, whatever material was there in different parts of the solar system, different kinds of planets were formed. Okay, in the region nearer to the Sun, 4 rocky planets, Jupiter, Saturn, Uranus, Mercury, Venus, Earth, and Mars were formed. And further away, very further away, Jupiter, Saturn, Uranus, and Neptune were formed. That is, they are gas giants. But between Mars and Jupiter, probably a rocky planet would have formed, I feel, probably. But the enormous gravity of Jupiter did not allow it to happen. That is why we see an asteroid belt between the orbits of Mars and Jupiter. That's the way it is.
Yes, sir. And next, Adil Pradesh of class 7th is asking that, sir, you say that both the moons of Mars are captured from asteroid belt by gravitational pull of the Mars, and a problem is that Phobos is coming near to Mars, but Deimos is going far away from Mars, and how that is happening.
Okay, to tell you very quickly, because of the way in which they are orbiting. See, Mars is actually spinning around its axis once in 24 hours, almost 24 hours, 37 minutes or 39 minutes. Phobos is actually revolving around the Mars in 5 hours or 6 hours, something like that. I don't remember. So Mars spinning motion is slower than the orbital motion of Phobos. So in that connection, Phobos is being slowed down. When you slow down something in an orbit to come nearer to the primary body, that is how astronauts will come back to Earth. So that is what is happening in the case of Phobos. Yes, they say after a few tens of millions of years, it's going to come and it may not hit the Mars, it may break up. But Deimos is further away. That is why it is not behaving like that. Very good question. Even, I never expected this question because I had read about this, okay, and thought about this, I could be able to answer. Thank you. Very, very fantastic questions you are asking.
Thank you.
See, our moon, for example, our moon you take. Moon is moving further away from the Earth. Every year it is moving away at a rate of 4 centimeters per year. Okay? Because why? Earth is spinning around its own axis once in 24 hours. Moon is revolving around the Earth once in 27.3 days. So this rapid spinning motion of the Earth due to tidal effect, it is accelerating the moon. That is, it is pulling the moon into a faster rate. That is why moon is moving away. The exactly opposite is happening in the case of Phobos. That is why it is coming towards Mars. Very good question, really.
Yes, sir. The next question is by Suryadev of 10th standard, and he's asking whether there is any relation between the Kuiper belt and asteroid belt.
See, asteroid belt is between the orbits of Mars and Jupiter, and Kuiper belt is very, very far away, beyond the orbit of Neptune, okay? Between 30 and 50 astronomical unit or something like that. That is between 30 and 50 times the distance between Earth and Sun. This is between 2.2 to 3.2 times the distance between the Earth and the Sun, this asteroid belt. But probably some of the asteroids formed within the asteroid belt, probably due to some gravitational interaction, they would have been thrown out towards the Kuiper belt, probably. And some of them might have come inside also, okay? Could be a possibility. The chances of something coming from Kuiper belt and entering the asteroid belt is more, I would say. That is the kind of thing. Good. Oh my goodness. Fantastic questions, really. I never thought students would ask these kind of things.
The next question is again by Vasudev of 10th, and he's asking, will asteroids revolve around other stars?
Yeah, why not? Why not? As early as 40 years, 40 years back itself, an American satellite called Infrared Astronomical Satellite, IRAS, I still remember at the time, reading this one, around a star called Beta Pictoris or Vega. It found a dust cloud around the star. See, I told you solar system was formed by a cloud of gas and dust. The planets were formed first by a cloud of gas and dust, and then planetesimals, and then planets, like that. So that kind of process might be happening there around that star. If are there asteroids around other stars? Possibility always exists, and Yeah, it should be possible. Why not?
Yes, sir.
That is.
Next question is by Adidev of 7th standard, and he's asking how much accuracy do we have in tracking asteroids, and what is the smallest size of asteroid we can track?
No. Can you repeat that? Hello?
Sorry, sir?
Can you repeat that?
Yes, sir. He's asking how much accuracy do we have in tracking asteroids, and what is the smallest size of asteroid that we can track?
See, how we are going to track, okay, if you want to track a small asteroid, okay, from the Earth using a telescope, how near it is, that depends. I don't know the exact distance, but even if it is very small, 200 meters in diameter, the DART spacecraft went. As you go nearer and nearer, the way in which you navigate towards that, the way in which you experience the gravity of that asteroid, based on that, you can track it very, very accurately. Okay, that information can be sent to Earth, and that can be used to refine the orbit of that asteroid. That is how they have found out that the orbit of Dimorphos has reduced, the orbital period of Dimorphos is reduced significantly. So that is the way. If you go near that, if you go to space using satellites, you can track smaller ones. I don't have the exact details, but using, the thing is, satellites and telescopes, the thing is, they want to track all the near Earth objects, that is, that which come to within 5 million kilometers of the Earth, and they have a diameter of about a kilometer or something like that. That is the thing. Unless you go near them, you cannot track them very, very effectively, very accurately. Because lots and lots of information you have to collect as to how they move in the arc of the sky. Yeah, next.
Okay, sir. Next question is by Agnivesh of class 9th, and he's asking why the moon is going further away from Earth.
Very good question. I answered one question and triggered another question. That is what is science, and I am happy he asked. See, moon and Earth, they have tidal interaction. Okay, tidal force is there. See, when today, in Kerala, you will see tides. You know what are tides? Okay, every 12 hours the sea comes up and all those things. In a single day, you have 2 high tides and 2 low tides, kind of thing. Okay, tides are mostly influenced by the moon. Sun also contributes, but it is relatively less. Okay, so this tidal bulge, whether it is water or whether it is land, okay, mostly water, there is a bulge due to the moon's tidal force, moon's gravity, let us say. Okay, this tidal bulge, because of Earth's rotation is once in 24 hours around its axis. This tidal bulge is moving very fast, that is once in 24 hours. But moon, which causes the tides, is moving slowly. So every particle in the universe, okay, it is attracted towards the other thing by a force which is directly proportional to the product of the masses, inversely proportional to the square of their distance apart, Newton's law says. So if moon generates tidal force, tidal effects on the Earth also responds. So when this tidal bulge is moving fast because of the Earth's rotation, that pulls the moon also a little bit quickly in its orbit. Whatever speed with which moon is moving, that gets accelerated because this tidal bulge of the Earth is moving faster than the moon is around the Earth, moving around the Earth. So because of anything, even if you have a satellite which is circling the Earth in an orbit, if you increase its speed in the direction of motion, then it will change its orbit and it will go to a higher orbit. That is what is happening to the moon, but it is so tiny. That is why it is moving at a rate of 4 centimeters per year. Only 4 centimeters. Mind it, moon is on the average at a distance of 384,000 kilometers, and it is moving only 4 centimeters away. So that is the tiny amount. But over a period of millions of years, changes do happen. I think I can take the next 2 questions. I have to leave now after that. I'm sorry to disappoint you. Next 2 questions I will take. And after that, I have some work. And more than that, Shadil Master, if you were to send me the email, the questions, definitely I'll be the happiest person to answer. But, I don't know how much of an education for your club members, for children, especially students, how much they have been benefited, I don't know. But I have been immensely benefited by this lecture because of the questions they are asking. Very, very thought-provoking questions. You kindly tell Kuti sir also. Okay? Please, next 2 questions. See, the thing is how they are asking. Fantastic questions they are asking. See, one question leading to the other. That's what I like. Okay? Yeah, next question.
Thank you. Yes, sir. Thank you so much for your compliment. And the next question followed is by Agnivesh again. And he is asking, we believe that the moon is formed by the collision of Mars-sized planet with the Earth. So why didn't the Earth form rings as well?
Actually, he was correct. What scientists say is when the thing is Thea or something like that, some people have named, a Mars-sized body in the early solar system, when Earth was in its primary school, it came and hit, okay, 400 crore years back or 4 billion years back at a particular angle, grazing angle kind of thing. That Mars-sized body was destroyed, and the upper portion of the Earth, top portion of the Earth was chipped off, and all these things were circling the Earth like a ring, it seems. But very shortly, all of them coalesced and formed the moon. That's what scientists say. Yes, it was the case. Yes.
Okay, sir. Thank you. Next question is by Shivanya
Last
Sanoj.
was for me. Yeah.
Sir. And she is asking that asteroids are dangerous to Earth, and similarly, do they affect other planets as well?
Why not? Why not? When you see the moon, the way in which you see the craters on the surface of the moon, it is the results of the hit of the asteroids and comets. Forget about moon, sir. After all, it is the satellite of the Earth, only at 4 lakh kilometers away. So near Earth only you see this. What about other planets? You see Mercury, it looks like moon only. Millions or hundreds of millions of asteroids have hit that also. But on Venus, you don't see. On Earth also, many craters are not there because they have been eroded by the wind as well as water. On the moon and Mercury, there is no water. That is why craters are still there. Yes, they have affected other planets too. No doubt about it. I think
sir, thank
this,
you.
I'll finish today. I have to go. Now I'm sitting in the planetarium and doing, I think this is the best judicious thing I have done. And this is not I am doing. I think I'm doing my official work also, planetarium work. After all, this is the objective of the work of the planetarium. Okay. Extremely happy, Shajil Master. Really, thank you. I'd love to come and give some of the talk. Please to come. Please to come. Yeah, let me tell you, it has given me immense satisfaction today. But I'm extremely sorry. I have to leave now and attend to some other thing.
Yes, sir. Yes, sir. Am I audible?
Yeah.
Thank you. Good evening to one and all. I'm Dwayne. I'm studying in 9th standard in St. Anthony's School. I'm a student member of UL Space Club. I'm very much honored and pleasure to deliver my word of thanks to the 64th webinar session of UL Space Club, the present golden era of asteroidal exploration. In the tapestry of life, every thread woven by gratitude adds richness and strength to the whole canvas. First of all, let me deliver my sincere gratitude to a distinguished guest and speaker of the event, Dr. B.R. Guruprasad Sir, the director of Jawaharlal Nehru Planetarium, Bengaluru, who helped us to explore the mysteries of asteroids, their significance in space exploration, and the latest advancements in this captivating field. Okay.
All Keralites they eat fish and then
Sir?
eat no flooded with
Sir, can I continue? Okay.
Continue.
Okay. I extend my gratitude to our dear Kutti sir, the founder and mentor of UL Space Club, who always guided and supported us. Also, I thank Shajil sir, who acted as a lamp in our UL Space Club. I also like to show my gratitude to all the dignified personalities like Jayaraman sir, Sundaramurthy sir, Ganesh Raj sir, and Madangal sir, who made this event grateful with their presence, comments, and reflections. We are indebted to the volunteers whose dedication and hard work contributed to the seamless flow of the program. I extend my heartfelt gratitude to all the attendees for making this event a success. In closing, let's acknowledge the collaborative effort that made this webinar successful. Thank you, each one of you, for being a part of this momentous occasion. I know and I'm sure that this webinar helped you to expand your cosmic knowledge. Once again, thanking everyone, let me conclude my words. Thank you.
Thank you. Thank you, Shajil Master. Thank you all. Yeah, we'll meet again, sir. Thank you. My pleasure.
Thank you, everybody.
Thank you. Thank you, sir. Good day. Good day. Good day. To all of you, Batra, bye.
Thank you. Thank you very much. Sir.
Thank you. Thank you. Bye.
Thank you.
Thank you.
Bye.
Thank you, sir.